Hi, myself Ami Bharat Gosalia, student of University of Windsor, batch of Fall 2021, would like to present the web search engine as the project of Advanced Computing Concept subject. Our team members are Suhail, Shivam and Ami. The presentation will cover following contents: introduction, concepts used, features, overview and the workflow, implementation, code walkthrough, project demo, future scope, references, project link. Introduction. What is search engine? A search engine is a software system that is designed to carry out web searches. They search the World Wide Web in a systematic way for information specified in a textual web search query. We use many web search engines in our day-to-day lives, such as Yahoo, Google. But did we ever wonder how does it work? The search engine works by crawling hundreds of billions of web pages using web crawlers, which can be referred as search engine bots or search engine spiders. Search engine navigates web by downloading web pages and follows links on pages to discover new pages that are available. When a user enters a query, all of the pages relevant to that query are identified and an algorithm is used and is hierarchically. But there is one difference that the ranking differs from one search engine to another. For example, the ranking of Google can be different from the ranking of Yahoo.
We approached the web search engine project by applying the concept learned in the course COMP-8547.
The concepts used are web crawler using JSON, HTML to text files conversions, search using TST, search using brute force methodology, hash tables for page ranking and edit distance for spell corrector. Our features in the process are in the web search engine are web crawler, which is UR crawling, search in TST, page ranking and searching using brute force, and spell corrector using edit distance.
For the input, the user gets yes or no as an input. If the user decides to enter the website URL, then that website is crawled using the web crawler. Or if he decides to select no, then the default gutenberg.org website is selected. After that, the HTML the crawler runs, and the HTML files are converted into TXT files by JSON. And currently we are limiting the number of files to be 20, but it can be more than that. Searching takes place using two methods, and the CPU timings are also calculated for each method. First, the word is searched using TST, and the time is displayed in milliseconds. And the second, the word is searched using brute force, and the corresponding CPU timings are also displayed as well. Also, if the word is found at a particular position and line numbers, it is also displayed in the console. After that, this feature is extended using page ranking, and the top 5 pages are displayed in which all the occurrences of the word is displayed. And the third feature is spell checking. It uses the edit distance algorithm and trees. So if the user enters the wrong input, then the output comes out to be the correct word.
First feature is web crawling. From reference 1, we understood how web crawling works in Java and how we can specify only one website link and get the web pages associated with the particular website. Second part of this feature is to use regex to infer the type of web pages that we are getting by the web crawler. Regex helps us a lot as we don't want any FTP locations or any other exposed APIs. We just want the text web page. More will be discussed in the code walkthrough section. After getting the web page, we convert the HTML web page into a text file for further processing for continuation of the second feature, and remove the redundancy for the third feature as it requires text files as the input. Second feature is TST search. We read all the downloaded files from the folder text_files and convert the complete file into tokens. By this we build the trie, that is TST in this case. We get the word from the user to perform the search. In this we find out the location in the file and the file name where this word occurs.
So implementation of the feature that I developed. So it uses the brute force search. It searches all the TXT files that were converted into HTML by the web crawler, and then it searches by brute force methodology. So the algorithm is the brute force, which it searches for the pattern in all the TXT files and returns the position, its particular position, and the program gives output containing the file name with the particular line and the position that the word is found. It also displays the CPU timing as well, and for after that, this feature is extended for the next feature, that is the page ranking. So it counts the number of words in every page, and then it ranks it reveals the pages as the top 5 pages with their word count in it. It uses hash table for doing that, and then after the hash table, it sorts the hash table and then reverses it to get the maximum number of words in the pages.
The next feature is spell corrector. So here we have used edit distance algorithm and tries for spell corrector and spell checker. So tries is a most efficient retrieval data structure. Using tries, search complexity can be brought to optimal keyword length. Edit distance algorithm, it is a way of quantifying how two dissimilar words are to one another by counting the number of operations required to transfer from one string to another. Edit distance can be used using dynamic programming, and it has various applications such as document comparison, plagiarism, DNA protein sequence alignment, and spell checking. The time complexity of edit distance algorithm is O and M, where N and M are the word length or the string length. So in our local system, we have a file with name dictionary text file, which contains all the dictionary words in the all the English dictionary words. Firstly, we will store all the words into a hash map as well as tries. And if the word entered by the user, that is, the user enters a keyword, the search engine goes and tries to find the word which is available in the try or not. So if the word is entered by the user which is correct, it has a correct spelling, then it would be available in the try. And if it is wrong, then it won't be available in the try. And then all the words from the hash map and the given wrong spelling word distance could be calculated using the edit distance algorithm. And finally, our application will return a single word with minimum distance.
Next, we go to the code walkthrough. The code is completely modular, and only the main class is used for communicating between various components. First, we get the input website URL. By default, we use gutenberg.org. After getting the input, we go to web search engine class, and in that we go to the crawl URL function. The parameters for this are URL string, number of web pages that we want to consider, and lastly the combination of all the URLs in the list. Here we ping the URL and filter with regex. Suppose we are reading Scientific American and we want to consider the articles of that. 3 in this case. We can add /article/ in the regex code. Another example is if we want to read books, we can use /ebooks/ in the case of gutenberg.org. Coming back to the main function, we have all the URLs. Now we ping to all the URLs and get the web pages and convert into text file and save it in the directory text_files. Next is to get the word that the user wants to search. For this, we use tst_implementation get all matches function to iterate over all the files present in the directory. Read each file in a single shot, convert it into a token via the string tokenizer library present in the Java utils. Then we show the location and the file name at which search word occurs.
From line number 62, the brute force algorithm starts. So basically, we take the word from the user as an input that the user wants to search across all the web pages linked to the website. So there is a separate file that is the brute pageranking.java. which takes care of the searching in the word in all the text files that were converted earlier from the conversion from HTML files. So in this file there is a method by the name search which is called from the main.java file, and in this method the file list is accumulated using list files method and stored in an array. So after this the array is iterated for every file. In that, in.java file is used, which takes the file as an input with the directory as its parameters. So the directory is inputted here. And line number 65, it reads all the line one by one, gives the line to brute force search method to return the position of the word. If the word is found, then it returns the position, else it returns -1, as you can see in this function. After the searching is done, output contains all the files with the occurrences of the word in the respective position and line numbers. So with this I have used the hash table to store unique file names and with the counters of the word. So it is counting for every file and the word that is searched. So then the hash table is sorted. So this is the unsorted one. The hash table is sorted using sort value function. This sort value function sorts according to the values, that is the number of words, the number of occurrences of the searched word, and then into ascending order, and then the list is reversed and it is displayed accordingly. So the top 5 pages are displayed. That's all for the code walkthrough.
Next, we have the project demo.
First, the user gets a choice to input a specific URL, or they can enter no to use the default URL. So default URL is gutenberg.org. Let me use this URL. Just scrolling through the web pages. Now the web crawler has ended the process. It has converted all the HTML web pages into txt files, and it stores it in the text files folder, which can be seen here. This is the folder, text files folder. After this process, the user gets an option to enter the word to search in those text files. The searching takes place using two methods. The first method is using the ternary search tree, and the second is the brute force via brute force method. So for both the methods, the CPU times are displayed at the end of the respective processes. So if I search the word A, so it searches via TST. This is the output, and it takes 90 milliseconds. Then it searches via brute force, and it gives the output as found at line 1, position 13, like this. And in the end, for both the methods, like the time taken is for the brute force is 46 milliseconds, and after the search, the pages are ranked accordingly. So according to the number of times the word has occurred in the pages, and this is the top 5 pages that are displayed with 10 occurrences, with 2 occurrences, 1, 1 and 1, and the total time is displayed as well. So after this, the user gets to input a word for spell check, and if I enter train, then it comes as an output that the word is not correctly entered by the user, and the correct word is train. And that is all for the spell checker.
So the future scope of the project is that providing usability and adding test cases using JUnit for unit testing of the code. Also, we can enhance the performance by adding more features, which could be like UI integration.
Following references are used in the project. This is the GitHub project link. Please feel free to scan it, and if you have any questions or doubts, we'll be glad to answer them. Thanks a lot for tuning in.